and welcome back to these webinars on end-user computing. My name is Paul Murray. I'm a solutions architect at Nutanix in Northern Europe, and in today's session I'd like to talk about the technical discovery and sizing of a Nutanix solution. So we've talked about a few features, a few functions of the Nutanix architecture. We talked about one-click upgrades, simple expansion, linear scalability, and things like that. So let's look at some of the technology, some of the architecture that allows that functionality to actually take place in a Nutanix cluster. So one thing I'll always talk about is the replication factor. The replication factor is part of the fundamental technology, the fundamental differences between a Nutanix solution and other technologies. And essentially what the replication factor does is it ensures that your data is protected and replicated for protection in the event of failures. I like to explain it by looking at the components of application performance. So there's various websites that will describe this. Basically, they all talk about three main components: IOPS, affecting application scalability; the bandwidth, affecting the application throughput; and then latency, which ultimately affects the application acceleration. Obviously, a balance of all those three is important, but that being said, those are the three main components when it comes to application performance. There are web resources that will talk about latency. One of ours is the Nutanix Bible. It's been written by our principal architects. So part of the foreword to this article, or to this resource, is the description of latency and how important it is in a computer solution or a computer architecture. Now, what this chart is depicting is the latency time, and comparing that to different situations, different scenarios. So the latency time, if we look at the bottom of the screen, the bottom of the chart, for example, for sending packets between California and Netherlands, all the way up to the top of the chart when we're talking about latency in terms of the level 1 cache on the actual CPUs. Now, if you look at the architecture, if you look at today's technology, today's hard drives, we are probably somewhere in the top half. So we're looking at NVMe drives, we're looking at 3D crosspoint drives, and then memory access itself. So what's important here is the higher we get up that chart, the lower the latency. The lower latency, the more performant your applications will be. So this is essential to the Nutanix architecture. Again, we talk about data locality, we talk about protecting the data, but it's nothing other than ensuring that the latency for that data, that the workload your virtual machine requires at that point in time, is as close to the CPU as possible. In terms of architecture descriptions, we talk about a thing called a replication factor. Now, the replication factor actually solves two challenges, so two birds with one stone. We're talking about data protection, and we also talk about data locality. So what these two features enable are things such as performance and availability. Now, the way it works is we will always read and write data locally, or we will always attempt to read and write data locally. So in a situation where your cluster is running normally, there's no degradation or anything like that, all the nodes are up and running, then, like I said, we're going to read and write locally. That is how we work. What that means is the data stays local on that node, so the data is on the same node as your virtual machine. If you think about the performance involved in actually getting that data, processing that data, obviously the closer we can keep, the closer we can maintain that data to your virtual machine, the better the performance. When it comes to protecting the data, this is where the replication factor kicks in. So we will synchronously replicate data blocks to other nodes in that cluster for high availability, for protection. Those replicas are also spread throughout the cluster for higher performance. So we're not just utilizing one node or one disk on a single node. We're using all of the available disks, all of the available nodes in that cluster to be able to do this replication, to be able to to be able to spread the replicas throughout the cluster. So that means that all the nodes are participating in replication. Thereby, we're eliminating any hot nodes. We're eliminating any bottlenecks when it comes to protecting the data. A benefit of this protection is that we have a thing called seamless VM migration. So your virtual machines can seamlessly migrate to any node within that cluster. That could happen for a couple of reasons. That could happen as an event through some sort of virtual machine load balancing. It could also happen through some sort of disaster. So a host, for example, crashes, or a disk in a host crashes. That's going to make a virtual machine migrate to another node. And what then happens is that virtual machine will continue to write locally. So the new node is the new local node. That virtual machine will continue to write locally. Like I said before, we'll always read and write locally. The problem here, though, is that virtual machine might need, or probably will need, some data that has not been written locally. So it's going to need to go across the network. The controller virtual machine, part of the architecture, show you that in a few seconds, knows where those replicas are. It will then read that replica across the network and store it on local storage for that virtual machine. So again, we build back that concept of data locality. We will only read the data that is required at that point in time. There's other solutions that will read more data. But like I said, in the Nutanix world, we only read the data that is required by that virtual machine to complete that transaction, to be able to complete that process. What this basically means is over time, we will always maintain this concept of data locality. If a virtual machine is relocated to another node, the same process takes place again. So as that virtual machine bounces across nodes, that's common in a VDI situation, but as that virtual machine bounces across virtual nodes or bounces across nodes, we're going to maintain that concept of data locality. So the high-level architecture, you've probably seen this before if you've worked with Nutanix, consists of multiple nodes, your user virtual machines, hypervisor storage, whether that's flash, spinning media, or all flash, and a thing called a controller virtual machine. So the little blue box, top right-hand corner of each of those nodes, the controller virtual machine. That's pretty much the orchestrator in a Nutanix environment. So the controller virtual machine is responsible for ensuring that the Nutanix cluster is up and running. Why is this important for VDI? Why is this data locality important for VDI? Now, if you think about the architecture as Citrix describes it or VMware describes it, the best storage is local storage. The best performance you're ever going to get or ever going to achieve is by using local storage. The downside of using local storage is scalability. So this is where the Nutanix architecture becomes extremely important. We have that concept of local data, like we've just seen. The desktop virtual machines, they see local storage. They're presented with local storage. But the Nutanix cluster maintains a distributed storage fabric across all of those nodes. If one of the virtual machines were to go to another node, then over time, a few minutes to be honest, over time that concept of data locality is maintained. So that leads into a thing called shadow clones. Now, what shadow clones allows us to do is a similar sort of concept, but if you're talking about VMware with link clones, instant clones, if you're talking about a Citrix world with machine creation services, you have this base virtual machine. That's your master image, your golden image. That's the image that your desktops reference to be able to boot up, to be able to get that Outlook.exe, to be able to get their applications and the like. Now, without Nutanix, as these virtual machines boot up throughout the cluster or throughout those different nodes, they're going to reference that base virtual machine across the network. So what Nutanix does, or what we do in a Nutanix world, if I can get this laser pointer up, is when a controller virtual machine detects that there are multiple remote requests from other controller virtual machines, then the CVM on this node, for example, on node 1, is going to set this virtual disk or the base image to be immutable. And as time goes on, as these virtual machines or remote virtual machines request data, it's going to copy or cache blocks of that original master image on these local nodes. So essentially we are caching parts of that base image or parts of that master image onto these remote nodes so that these remote virtual machines can access local data. That brings in a big benefit. It's probably better described as distributed caching of those virtual disks, of that VM data. That's essentially what it does. As time goes on, as the controller virtual machines on remote nodes detect that there's a lot of remote or network activity going on, it's going to start to cache parts of that master image as is required for that virtual machine to be able to boot up, to be able to access Outlook or whatever. We call it shadow clones. It brings in a lot of performance benefits. So some of the benefits are expressed in terms of a test. So in this situation, we had 4 nodes running AOS, whatever version, ESX and Horizon or VMware Horizon 7.8. So it's not just a Citrix, it's not just a feature that helps the Citrix world. It helps the Horizon View world as well. Again, in this example, 4 nodes, 400 users. What we're seeing there is the boot time is reducing from sort of 6 minutes, 40 seconds down to 4 minutes. That's a reduction in about 40%. So by turning on the shadow clones, so we're not using the virtual storage accelerator from VMware, but by turning on shadow clones, the boot times are reduced by about 40%. If we look at Logon Times, not as significant, but nevertheless there is a reduction or there is an improvement in the Logon time. So your Logon time is about 5% faster. Now this is for a cluster of only 400 users. We talked about linear scalability. So as you scale out that architecture to thousands of desktops, this Logon time is going to stay the same. There are other technologies out there which don't have that linear scalability. So again, this is just an example of 400 desktops, so the difference is not that much, but this difference will increase as we scale out that architecture. So in the Nutanix world, the Logon time is going to stay consistent. In other technologies, this Logon time is going to degrade and get higher and higher or slower and slower. Same with the user experience. 400 users, there's not really that much difference. But again, what we're seeing here is it's 5% lower, so the user experience is better. Again, same as the previous slide. As this solution scales out to thousands of users, that user experience is going to stay consistent. With other technologies, it's probably not going to stay as consistent. What this means in terms of numbers, in terms of the Logon VSI description, is we're talking about a good solution, so without shadow clones, so it's just a good solution, comparing that to a very good solution. I know it's only a word, but there are big differences, especially when it comes to scaling out that architecture. So let's talk about provisioning. I mean, obviously we need to be able to provision these virtual desktops. There's 2 technologies. If we look at the Citrix world, they talk about provisioning services. It's a network-based provisioning. We can't optimize that, apparently. I'm going to show you differences that we can actually optimize PVS world. And then there's machine creation services. By default, it's a storage-based provisioning. That's what Nutanix does. So we changed the whole storage concept so we can drastically improve the machine creation services. But not getting into this discussion about PVS versus MCS, we can also improve the PVS infrastructure. So a couple of examples, we'll go through PVS and machine creation services. So I'm not going to go through all the details between, or the differences between pooled desktops, dedicated, whatever. The assumption is you understand all that, but the differences between the architecture. So on the right-hand side of the slide, if we look at the MCS architecture, very simplistic compared to provisioning services. So we have the Citrix Studio piece, the Zen desktop site, so your desktop controllers, or your desktop delivery controllers, use the old words, the data store, and then your virtual delivery agent, hypervisor, and storage. So this piece down the bottom, shared storage, write cache, whatever, that's the Nutanix world. We simplify this because we are, in that sense, we're a storage vendor. That's what we started with. That's what we changed significantly when we came up with this hyper-converged infrastructure. That is essential in a virtual desktop world. Where we can further help, or where it further simplifies or where it further resonates with admins, is we simplify the MCS architecture even further. We don't need shared storage. We don't need that SAN type architecture. Nutanix cluster providing that storage to your virtual desktops. Simpler configuration in Desktop Studio. So the Citrix admins, you know, things like the Hyper or the HCL, so the Hypervisor Communications Library, basically how Studio will talk to the underlying hypervisor to tell that hypervisor, go and spin me up 10 virtual machines, or power these virtual machines on, power these virtual machines down. We've got an integration, so there's a plugin on the DDC. There's a few files that you need to install. It's essentially that plugin into Desktop Studio. So you right mouse click in Studio, you create your machine catalog, and then you select the Nutanix cluster. So again, simplifying the administration in a Citrix world. What that means in practical terms is there are fewer multiple image copies. There are fewer data stores. So again, simplifying the data store concept in a Zen desktop deployment. And there are less I/O issues, fewer I/O hotspots. Again, one of the big benefits around Nutanix is we can scale out as is required. So we don't have to design the storage system and all the IOPS that are always talked about for what might happen in 2 years' time. We design it for those 300 desktops that you want to deploy today. And as you want to scale that out, as you need to scale that out, we add in additional hardware. Linear scalability, one-click expansions, like I've mentioned a few times. So essentially, we improve the VM movability, we reduce the boot times, and that ends up with a better scalability overall. So provisioning services. Again, people make the assumption that we cannot improve provisioning services. Similar sort of story to machine creation services I go through. So I won't talk about the difference between streams, personal vDisk, virtual, physical, whatever. Again, the assumption is you understand all that. But then let's take a look at the actual architecture. So this is why people say provisioning services is more complex or overly complex. First off, it's a good technology. It works. It works extremely well. But if we reduce that down to a virtual desktop infrastructure and the requirements there, I have my Zen desktop site as before, so the DDCs, the data store, Citrix Studio, the management console, and then I have a complete architecture for provisioning services. And provisioning services is a very powerful set of technologies, probably too powerful for a simple VDI infrastructure. Not getting into that discussion, but like I said, the PVS itself has its own architecture. So the PVS server or servers, if you want high availability, data stores, and then your disk store. So your images that you want to push out to your virtual machines. Then there are things such as the virtual delivery agent and the PVS target devices. Again, you can have multiple copies of those, and your hypervisor. Down at the bottom, again, similar to the MCS concept, shared storage or locally attached storage with different write caches or whatever. Not going into all the different write cache abilities with PVS, but that's the main difference between MCS and PVS. PVS is more powerful compared to MCS. Whether I need that ability in a simple or a pure VDI desktop deployment is debatable. That's where a lot of the confusion, that's where a lot of the arguments arise between PVS and MCS. So can we optimize provisioning services? Again, a high-level overview of what PVS can do. So there's two areas we'll talk about. First of all, the write cache. As you know, we have this master image or golden image that is streamed down to your target machines with provisioning services. At some point in time, they need to be able to write information to a cache disk. That cache disk can be on or part of the virtual machine itself. We can write to cache in RAM. We can write to cache in RAM, and if the RAM fills up, we can overflow to disk. Wouldn't recommend it. Again, the reason I wouldn't recommend that is we can't guarantee the performance. There's going to become a point in time where it's going to need to overflow to disk. That could affect the overall performance, the running performance of that virtual machine. But that being said, like I said, there are different abilities or different possibilities for your write cache. This is all storage. These vDisks, virtual disks, they're all stored somewhere in storage. So we can optimize that, a single container on your Nutanix cluster as that storage location for your write cache. Then we look at the device collections themselves, the provisioning servers. Again, we can optimize those. We can store those. We can run those on a Nutanix cluster. So if a customer says, but you only optimize machine creation services, and if that customer wants to stay with PVS, there are reasons, not going into all that, but if that customer wants to stay with PVS, this is an example of how we can improve the provisioning service architecture, simplify that provisioning service architecture by running it on a Nutanix cluster. Then let's take a look at some of the benefits of provisioning services on a Nutanix deployment. First of all, there's no need to manage the local disks. Your disk space concerns are reduced, and also the write I/O concerns are reduced. This leads into better virtual machine mobility, into a simpler write cache configuration, which ultimately results in a higher virtual machine density on your Nutanix nodes. You may also be challenged with customers when they say that they've heard that Nutanix really only benefits a machine creation services focused deployment. That's not true. Nutanix also benefits provisioning services. We've seen some of those. So there's no need to manage the local storage for your write cache. There's no need to look into high availability or RAID solutions for your PVS setup. That's part of the Nutanix architecture. Things such as local disks filling up and crashing virtual machines. So the write cache considerations are a lot easier or a lot simpler in a Nutanix world. All of those components, all of those statements, they lead into, or they result in better scalability, results in a higher virtual machine density on your Nutanix nodes, and overall leads to less management overhead. So ultimately a win-win situation. So provisioning services works perfectly okay on a Nutanix cluster. I'm not going through the discussion whether it should be MCS or PVS, but just want to say PVS works perfectly okay. So that being said, that's the end of this part of the series. So keep rocking those socks. I will explain what it all means. So I'll do that in the final session. I decided to make it to turn into a 4-part session. This one would have been just too long. It would have been almost an hour. Like I said, what was a 3-part series is now a 4-part series. Keep rocking those socks. Thanks for listening, and speak to you next time. Bye-bye.